Can everyone see that healthy soil under the microscope? And of course, my good friend, George, oh, sorry, this nematode here. Okay, so what we're going to talk about a lot is composting. And so that to me is one of the best things you can do to grow nutritious food and help and maintain living microbes in your soil. So let's carry on from there. This is always a scary statistic. This was 2015. It was the year of the soil, but they also talked about, based on the fact that it takes 1,000 years to create 3 centimeters of topsoil. The statistic is that we're going to run out of soil because of soil degradation in 60 years. So frightening. I don't think that we are, because I think that using these regenerative ag principles that we're talking about is going to save us, which is why I'm here. And I'm sure that's why you're here. So this wonderful quote from the UN, a healthy soil is a living dynamic ecosystem. So basically what we're finding is that the crops that are being harvested are showing really scary signs of decline. And a lot of that, so nutrient decline, and they're saying it's because of the chemical fertilizers and over farming that's causing the trouble. And this is always an interesting statistics here for me, the organic versus conventional nutrients in each type of plant that you want to grow. So knowing that there is a lot of effort towards unlocking the secret of in the soil, as the USDA Natural Resource Conservation Service states. And they quote say, soil is a living and life-giving natural resource. So I think we're all convinced of that now. And what we're going to focus on are some of these regenerative agriculture principles that are going to shift the paradigm from this competing with nature to really partnering with nature. And that's what it's all about. So when you're talking about dead soil, this is the NRDC now, comparing living to dead soil. And here's some visuals of bare soil. If you see bare soil, you know that it is bacterial dominant, and that there is very little life, because life cannot survive in dead, bare soil. You're going to get erosion because there's nothing holding that soil together. You're going to be more and more dependent on chemicals, and you're going to have weeds because you have a bacterial dominant soil. So all of things we talked about last week. And these are farming problems that we have. So tilling, growing food in a monoculture, removing any crop residue, not allowing it to decompose in the soil, and of course, chemicals. The other thing with farming, of course, is overgrazing is a major concern. If we're talking about gardening, it's a little different. Rototilling, of course, is a problem. Monoculture, and here's the perfect example of the monoculture that hopefully is losing favor, and we're seeing it for what it is. And it's not how soil wants to be. Removing crop residue. Anytime you turn over, or what we call double digging or digging the soil, you are disturbing it and disturbing the life in the soil. And of course, any chemicals that you're putting on will disturb the soil. If you haven't seen the movie Kiss the Ground, highly recommend it. This is a graphic from there talking about regenerative agriculture. And when we're looking at it from a farming perspective, we're talking about cover crops, we're talking about perennials and trees, we're talking about compost or mob grazing, and we're talking about no-till. If we're talking about home gardening, it's the same principles. We can incorporate cover crops really nicely in a home garden. We can plant perennials and trees. We can compost, which we're going to go into in detail. And of course, minimal disturbance in our garden beds. So here are some other things that we're going to be looking at: companion planting, crop rotation, intercropping, succession planting, and we're going to start by talking about composting. So as Elliot Coleman, the true hero of mine, he's growing food year round on 2 acres of land in Maine, he does think that producing quality compost is the most important job that we can do. And this is an excellent book if you want more detailed information about composting, where when we talk about compost and composting, it's really transforming organic waste into a soil building substance, which is suitable for farm, orchard, or garden. So there are a lot of these statistics. Again, this is recorded, so you can refer back if I'm going too quickly through all of these. But one of the main benefits of worm composting is nutrient retention. So adding those nutrients back. Pest and disease suppression. So what we're finding, and we looked at a test trial last week where the soil was healthy. And because of that, the plants are healthy and they have a stronger immunity to pests and diseases. And it also helps to build soil structure. And we're actually going to take a look under the microscope at different types of compost, and we'll see those beautiful aggregates that are in the soil. This is some soil that we took from the garden beds that we were testing a couple of years ago. And it's beautiful soil, lots of aggregates. But what we found with the soil, it was bacterial dominant, amazing numbers of bacteria. So let's take a look at the compost that we wanted to apply. And I was thrilled to find not as much density of bacteria here, but excellent fungi. So we knew we were going to end up with a really nice bacterial fungal balance by adding this compost to the soil. I would recommend getting not only your soil tested, but the compost that you want to use, just to know that what you're adding is going to complement what's already there. So a microbial life in the compost varies, as I just talked about. So it depends on what you're putting in and also the method. This is from Max Hence's farm. A lot of bacteria moving around.
That's so cool.
400 times magnification.
So cool.
We're looking at unscreened compost from Grillo Services, and this is 400 times magnification. Plenty of bacteria. I'm not seeing any fungal to speak of, and no predators. Okay, this is Earth Care Farms compost, and we're looking at 400 times magnification, 1 to 5 dilution. Earth Care Farms, 1 to 5 dilution, 100 times magnification. Coast of Maine topsoil, 1 to 5 dilution, 100 times magnification. Coast of Maine topsoil, 1 to 5 dilution, 400 times magnification. Plenty of fungal hyphae and diverse bacteria. So what I find ironic about this is all those amazing composts and the topsoil from Coast of Maine beat out. I also looked at their potting soil, I looked at their compost. The topsoil had beautiful, as you can see, fungal properties, which I was not expecting. And all of the compost, and that's what I was going to mention earlier, that I test, I would say, besides the one I used for that test trial, was very much bacterial dominant. And so that's a real problem, because we then we're selecting for weeds if we're using compost that is bacterial dominant. So always a good, and I would recommend, if any of you can get a microscope and you can see how easy it is to learn it, and so you really know all of the inputs that you're putting into your farm. All right, I'm going to dive here into carbon to nitrogen ratio, which I find is the basis of any type of composting you want to do. And basically, we're talking about a balance of the carbon to nitrogen. So if you look here, here are some high carbon materials. Wood chips, for example, 400 to 1. So that's why if you just put wood chips on soil, it will absorb the nitrogen from the soil to help with the decomposition, because it's so lacking. And so if you look at high nitrogen, of course, food scraps, 20 to 1. So all of these are falling below what we want to have as our sweet spot, including, surprisingly, coffee grounds. Alfalfa being one of the
highest nitrogen inputs, besides, as we're going to find out, spent hops. So I'm going to backtrack a little bit, but just so you can remember that if you have excess carbon, so you have a high carbon ratio, you're really going to slow down the decomposition. If you have excess nitrogen, you're going to end up with a stinky pile. So it's really important to make sure you have that nice balance. These are the three types of composting that we're going to talk about: hot, thermophilic, and worm composting. So we're going to take a trip now to California. I'm here visiting Dr. Ingham at her farm, and she's teaching us how to do thermophilic composting. 20 buckets we're using here. So we have 2 buckets of high nitrogen. We have 6 buckets of green, which I would consider perhaps more brown, including hedge trimmings and landscape trimmings and vines. 12 of those buckets are high carbon. So wood chips, straw, horse bedding, and all that thing, all of those elements. And so we're starting with, we're going to soak all the materials. We're going to create, in this case, a mesh bin. And then we're going to add those components. There's all the 20 buckets there. We're going to intermix them and add them to this bin. There's Dr. Ingham, and there's the bin in the background. And again, watering being key. And that reminds me, we're going to talk about the Johnson-Su method next week, talk about high carbon or carbon inputs only for a different type of highly fungal compost. So this is the finished bin. And then what you want to do, and this is for thermophilic regs, maintain a temperature of 131 degrees for 15 days, turning the pile 5 times. Now, the reason you want to do that is you want to take the outside of the pile and put it on the inside so that all of those elements have reached 131 degrees, not just the inside of the pile. And the reason that number is key is that's when you can destroy pathogens. And 145 degrees is actually when you have weed seed destruction. So if you're putting in weed seeds, if you're putting in manures and all of those things, these regulations are really important. And that's just an example of the heating up process. This is the thermophilic, which usually, as I mentioned, 15 days, and the maturation process, which can take 6 months. All right, so now we are at Reservoir Community Farm, and where the interns are here, and we are doing our own version of the thermophilic composting. So we have our 12 buckets. What I didn't realize is the wonderfully donated spent hops that we're using has a carbon nitrogen ratio of 12:1. So now we are adding very high nitrogen as our source. So a day later, we come back with when we check the pile, it's 165 degrees, it's overheating. And so the job is to turn the pile. It should have taken 3 or 4 days to reach that temperature. And it really didn't stink. It did stink, didn't it? It was not a pretty picture. So this is Saturday. Sunday, I wake up in the morning. Oh, I'm cheating and showing you what the result is, but that's okay. So I wake up in the morning, I rush over there thinking, oh, shoot, I think I might have added too much nitrogen. And I take the thermometer, stick it in, it's 178 degrees. Oh my goodness, I think this thing's gonna blow. So I have no choice but to just take the whole thing apart and left it like that. Of course, all the neighbors are slamming their windows, and it was not a pretty picture. And I learned my lesson. Thermophilic compost is really, you really want to get that nice balance, because if you ever see a compost heap that is steaming, it's steaming off the nitrates, which is, as Steve Solomon so clearly points out in this wonderful book, The Intelligent Gardener, the last thing you want. So let's move on, shall we, to a simpler type of composting, static compost piles. And what I love about this is it's pretty user-friendly. The recipe is a little bit more lenient towards greens, and you do it, we call this lasagna composting, and it's literally layering different elements. And I have another picture here. And you really want to avoid, in this case, because you're not going to be reaching that 143-degree temperature, you want to avoid weed seeds or vegetable seeds because they're not going to be killed off. I would not recommend any manures or meats or fish or anything like that that might draw rodents or because that's not going, no pathogens are going to be killed. And you do want to layer, and one of the layers is water. You really want to make sure it stays moist. Grabbing soil from your neighborhood and your yard or your farm and incorporating that is also really important. And this is the system I have. And just so that that rodents don't get in, and it'll decompose and shrink down to 80% shrinkage, and then you can harvest out of here and what I call black gold. So that is a much simpler way of composting, and I in fact do two, and I'll explain why. Of course, I do worm composting, and I hate to go at length here, but I will because I'm a true believer that the worms, incorporating the worms into composting, they are doing all of the work, and they are really the most effective way to compost. And they actually, it's using the worms to recycle food scraps. And what you get as an end result is what we're calling vermicompost, worm castings, or worm compost. We went with a food delegation now 7 years ago to Cuba through the Schumacher Center for New Economics. We visited 12 different farms. Every farm, their only input was worm compost. They don't have access to chemicals. And so I was amazed to see that they had perfected worm composting to a huge degree. It was really, really impressive. And the food was amazing. And everyone seemed very healthy. So it definitely convinced me. This, of course, was written by a worm farmer, but he's comparing worm castings to compost. And he is talking, and I've seen through the microscopy that there is a much greater diversity of microorganisms. It really does help with, for that reason, the health of the food and the soil. Things grow faster. It's faster to create than regular compost as well, because the worms do all the work for you. Here's some other things talking about benefits of worm composting. Again, because of the aggregate formation, it really helps with the physical soil structure. And because those aggregates hold water, if you get the water holding capacity. And of course, you're adding, when you add it to the soil, that multitude of microorganisms. And so I could go on and on. Here's a quick example of numbers. Check out this is a regular soil test, but you can see compared to regular soil how all of the nutrients are available in there. Different types of worm compost systems. I really love this one. Is in New Zealand. This is this is worm bins in New Zealand. They're taking it very seriously. So a quick look at some research and trials. We're finding that worm compost can promote 30 to 40% over chemical fertilizers, and it is of course much less expensive to do. And then compare that to topsoil, and you could see from that soil sample that these figures are correct. We did a quick look at, love doing test trials. So here's an example of just taking your soil starting mix and what happens when you add 10% worm castings. Just some other examples. We were also surprised to find when we did this example, this is 4-month-old castings as opposed to castings that were fresh. And I was not expecting this. In fact, that's why I put this one, it lived in the center here. I assumed that it would be less, and you can see very little growth on the control. But what's happened is, as long as you store the worm castings in a soil retentive moisture, a moisture retention breathable plastic, and there is something, it's called a cordon fish bag. They use it to ship goldfish around the world. It allows oxygen exchange, but keeps the moisture in. And I might have mentioned it last week, I'm not sure. But what we find is when we store our castings in that, though there are still some worms in there and the microbes are in there, they continue to do that nutrient cycling. So the longer it sits, and now they're saying up to 3 years, those worm castings have more nutrient plant available nutrients, and that was evident from this test trial. This is an excellent book if you get a chance to purchase, Teeming with Microbes, and they're talking about vermicomposting having as much as 7 times more phosphate, 10 times the potash, as we were talking about already. Okay, so now let's take a look here. This is a very simple starter system if you would like. Make sure you put some holes in there for breathability. Here are some other home systems that you can purchase. And then I'm just going to give you some quick, and I'm going to fly through this because you might not want to do worm composting and go, yeah, okay, thank you very much. But it is really easy to start. So you would get soil from hopefully your own farm or garden. So you would inoculate. If you go closer to a tree, you'll have the more fungal dominant soil that you're adding. You can add shredded paper and cardboard. I'm using less of that and more of organic ingredients that might have living microbes already. And for this sort of setup, you'd need about 1 pound of worms. Not that I count them, but there are roughly 1,000 worms, and they're Icinium fetata is the ones we use. And they're called red wigglers. And they're really efficient at breaking down those food scraps and work really well in these home composting bins. They're adaptable, they tolerate being moved, they really don't want to go out of their bin, which is helpful, and they multiply quickly. So all good reasons to use red wigglers. You might ask what they eat. Well, here's a list of things they eat. What I'm finding, no matter what the list is, it really is going back to that carbon-nitrogen ratio. You really want to have a nice balance. So what we tend to feed our worms now, we have a sort of a it's been, since we started the business, we've been doing it for about 7 years. We have a standard regimen now of thermophilic compost. So only leaves, so it's certified organic. So all of our inputs we make sure are vegetative and organic, certified organic. So our thermophilic, certified organic thermophilic compost, we add trace minerals in the form of basalt rock dust, and we will also add various other grains, non-GMO organic. We were putting steel cut oats, it became prohibitively expensive. So now we're adding certified organic cornmeal, and that seems to, according to Uncle Jim's, it seems to help with multiplication of more worms, if you will. And we also add vegetable waste, and we get our vegetable waste now from an organic juicer bar. Just keep in mind, any organic waste vegetables that you're putting in there, if you put in seeds, they're probably all going to germinate. So if you're putting in the end of the pepper or the tomatoes, you're going to have volunteer peppers and tomatoes, which can be a problem if you're trying to grow seed start peppers and tomatoes. Which one is the actual one you planted? So I would suggest not adding that and not adding anything like onion and garlic, but I go into that. So saving your food scraps, it's a wonderful use. I do save coffee grounds, but keep in mind that that's pretty high in nitrogen, much higher than I expected. And again, the yucky ones, nothing that is too acidic, no breads, or that can add gnats, nothing too spicy or salty, no sugar, processed foods, things like that. And here are some more examples of greens and browns that you can put in. Taste treats. Okay, so what I find out, I'm now buying melon, cantaloupe in particular, they seem to like, even though I don't really like cantaloupe, but it's a sacrifice I'm willing to make. I'll eat the cantaloupe because the worms love the cantaloupe rind. So you just stick a cantaloupe rind under there and it becomes a party. And you seem to get more worms after that So I don't know what they're doing under there, but it's really a nice treat for them, as are these other elements. What not to feed worms, and we talked about that. Obviously, any grass or plants that have been sprayed, so don't put that into anything like if you have a static pile, try to avoid, if you don't know where it's from, or you use any type of pesticide, don't use it in your compost. Any meat and poultry, of course, because although going through the gut of the worm will kill pathogens, you're not guaranteed that every little speck of your worm bin will be penetrated by or will be consumed by a worm. So just avoid those types of things. Dairy products, manures, I'm finding. The reason we don't add manures, I'm just going to, I'm going to go back so you can focus on that while I talk. We really like to use worm compost, and I'll talk about this next week, to make compost tea. Because as you've seen, it should be, especially if you're doing it yourself and you're doing it correctly, teeming with microbial life. So that microbial life, you want to make sure that it is free of pathogens, because we want to take the worm castings and turn it into a tea. And you want to be able to spray that tea up until the day of harvest. So what we ended up doing is we wrote the regs for worm composting, but we also wrote the regs for worm compost tea so that we could use it up till the day of harvest. So the regs are very strict in terms of vegetative inputs only, certified organic inputs only, and testing it under the microscope so that you know that you're not applying pathogens or anaerobic microbes onto your whatever you're trying to grow. So anyway, how much to feed? Well, we used to feed every 3 or 4 days. Once they're established, though, we like to cut down to once every 7 days. And the reason we do that is the worms will then go through every bit of the food that's there, rather than only go to the new food that you add. So it makes it pure castings at the end of the day. And then if you see any food that's just sitting there, you know it's going to attract fruit flies if it's still sitting there 3 or 4 days later. This is a worm bin at a school. I came back and they were wondering why they were having a fruit fly problem. Just know that the worms are going to eat food that is decomposing. It's going to take a while for these apple cores to decompose. So remember that, and only put in food scraps that are in the process of decomposing. If you do end up with peels and things like that, there are several ways you can get it ready for your worm bin. You can put it in your food processor. You can put it in a Ziploc bag and stick it in your freezer, and that helps break down the cell walls. We used to, and then this got old, but we used to dig a hole, throw in all of the food scraps we'd get from the organic restaurant, and put a flag and dig it up 3 weeks later and use that for worm composting. But then going to the organic juicer bar, where everything had already been, we were taking the pulp of these incredible vegetables and we trained them not to add fruit seeds. That was really the easiest method, which is what we're doing now. Temperature control. There are different ways you can do it. I really like this example of adding these hay bales as insulation. And what I like especially about this on a farm situation is, of course, the microbes are going to start inhabiting the edges of these hay bales. So if you use that as mulch in the spring, they'll already be inhabited, but with microbes. This is another example where a hole was dug and put in the ground. We've been successful with a worm bin outside here, where we took a seedling mat and put that on the surface, and we set the temperature so it only turned off if it went below 40 degrees. So it maintained 40 degrees outdoors. And this is year 3, and the worms are doing great. I should probably put a picture of that in there. So there are ways you can do it. We have one in an unheated shed at the farm, and that again, we just use that larger seeding mat. So as long as it stays above 40 degrees. And then literally 3 months later, you can start harvesting, as opposed to thermophilic, which is all that labor intensive. And then you still have to let it cure for 6 months, and there are no microbes. This will have microbes throughout, and it's also should smell like the earth. And it's a wonderful soil amendment. So I'm just going to check on the time. So we have 20 minutes left. I'm going to stop here for a minute because I'm going to talk about these other regenerative ag principles. Okay, so the first one here is succession planting. It's a very quick example of it, where you plant a small quantity of a crop on a regular basis, so that you can harvest in intervals. And these are some crops that do well for succession planting: lettuce, basil, cilantro, and bush beans, something that you harvest at one time. Then if you could have, I don't know how many bush beans one day, it's okay if it's a market garden. But if it's for your own use, or you want to be able to sell beans throughout the season, planting beans every 2 weeks is a great way to have fresh beans throughout the season. Also, root vegetables, what you find that everything is ready at the same time. Carrots, although I will say, pulling out baby carrots to make room for the larger carrots to mature, it might not be necessary. Intercropping. So this is something I'm doing more and more of, and working together with companion plants so that you can intercrop beneficial flowers that will benefit the crops. There's a lot of information about ways to intercrop. And it also benefits both plants. So the whole thing about companion planting is another story. And also intercropping with onions as a pest deterrent for other plants. Here's a great book on companion planting. So plants that actually really complement each other. And this will be available if you want more information about different plants that go together well. Oh, I guess I included some: marigolds and melons, tomatoes and cabbage, cucumbers and nasturtiums, radishes and spinach, and broccoli, dill, and rosemary, to name a few. And of course, the most famous one through the ages is the Three Sisters garden with the corn, squash, and beans. Crop rotation is also something to consider, with a lot of benefits, including feeding the nutrients from one crop. Say you have peas or beans that are legumes and have a higher nitrogen, and then you follow that with a brassica it needs more nitrogen than it gives. So using that, and here's an example of a way to do crop rotation. And working with nature really is what we're talking about. Again, a legume followed by a root, followed by a fruit, or a leaf crop like a lettuce, all helping each other as you leave the decomposing plant there for the next year. Cover crops. On a large scale, of course, in farms, we're seeing them more and more, but you can also do it in a home garden. And again, it's wonderful for soil structure and organic matter, and is also the new word, green manure, and it adds nitrogen and a number of nutrients for the following crops. The interesting way and I love this example of using cover crops as a mulch or fertilizer, where these potatoes are interplanted with the peas. And so this is as it grows up, you can see complementing each other, and then living cover crop as dinner, as it turns out. So you can harvest the pea shoots of the cover crop. Buckwheat is probably my favorite cover crop, especially if you're wondering what to do with a field that you've just harvested for spring crops. It's a wonderful pollinator and adds so much to the soil. And so here you can see it growing with it looks like that's some kind of squash in there. And it can hide vegetables from the pests. So it's a wonderful disguise as well as it's coming up. So again, you could let it go to seed and make buckwheat pancakes as we did with our interns one year. But what we generally do is we'll cut it down 5 to 7 days after flowering, and then you have the whatever you cut off is going to be a mulch for your beds. So as I'm going to leave you with, it's all a question of life, and life in the soil being something we're just learning about, but I think we're going to find is really going to get us to to bring soil back to life and to be able to build our own soil.
Fantastic. Anything else, Monique?
No, thank you everyone for being here and for caring so much about soil and